Welcome back. This is the third lesson in the topic of binary search trees, and in this lesson we'll look at how to show a binary search tree in a 2D array. We've already looked at putting trees into arrays, and this is very, very similar. In this lesson we'll look at making a binary search tree in a 2D array and how we do those operations of adding and finding data in the tree if it's implemented as an array. Do you remember this 2D array? We used it last week and it's storing a tree. I don't know if you noticed, but it is actually a binary search tree, and the left and right pointers are numbers that tell us where the different nodes are in the 2D array. Last week we did this, inserting the data value A into the tree. Last week I said just put it there, going off to the left of C. Now you'll see that the reason we've put it there is because that's the right location for it in a binary search tree. So in the exam they might just tell you to add a particular value to the tree, and you'd have to work out the right place to put it and then make the pointers, change the pointers to add the value at that position. Now you could draw the picture of the tree even if they don't ask you to. If it helps you to do the work, just do a little drawing of the tree, because you might find that easier than working with the array, and literally that will be fine. And then once you've done that, you can see where the data goes, in this case to the left of C. So you create the new value and you change the left pointer of C to point to the new value. So don't hesitate to do a little drawing if it helps you. Okay, so here's another example. This is a tree that is storing the names of trees. Very clever. And it's only got oak, cedar and pine in it at the moment. And add these values, ash, maple and willow, in that order to the tree, and make all the pointers work properly. So pause the video now. Do that just on a bit of paper. You can draw the tree if you want to, and that might help you to put the pointers right. Okay, so on the next slide I'll show you the answer. So stop the video, do the work. Here's the answer. There's the little drawing of the tree of trees, and I've put in all the values and the pointers to make that work. So you can see ash, maple and willow are leaf nodes, so they don't have any pointers. Oak, cedar and pine do, and all those pointers work to join up the nodes in just the right way. I personally, because I'm a bit visual, I like doing a little drawing, but if you don't want to, if you can manage without, that's fine as well, of course. So here are the same values, but they're in a different order, and you know what that means. It means the tree will look different and the 2D array will be different. So this is your activity to create a 2D array that stores a binary search tree holding those 6 values added in that order, with cedar as the root node, adding the other nodes in that order. And you can email me the result, scan it, draw it by hand and scan it, or make it with graphic software or whatever. There is an extension activity on the next slide, but this is very, very optional. So the optional stretch and challenge activity is to try to write a program which creates a binary search tree in a 2D array. You could use the array that you've just made, and you could hard code that array, those data values in if you like, and then write new functions to append and find data in that array by following the pointers. And and if you prefer, you could do it using object-oriented programming. I will give more support about how to do this next week, but I think this should be considered optional for those of you who want to master the programming. Most of the questions on trees will be about drawings of trees or the 2D array set out as a table. But I think this is an interesting additional challenge, and I will revisit it next week.